Hey everyone, this will be a video on 4.1. So the first question here we have a small plant manufacturing riding mowers. Okay. So we have a plant that's manufacturing this. The plant has fixed costs and variable costs. So we have the fixed, we have the variable, and we see that ties into our cost equation exactly, that the fixed is without the x, it's like the intercept, and the variable is like your slope. And the mowers are sold for this much. So this is your revenue. This is like, if you kind of remember, your C of X is MX plus B, and like your revenue in this case, it's just, since we already have a mower for each, how much we sell it for, you can think of it as just like KX in this sort of problem. Okay. So we get, that's how these are formed. So how many mowers must be sold to break even? So we could, you want to think, that means when revenue equals cost. So one approach here is we just type all this into Desmos, or you could solve it, set them equal, so it's really up to you. I'm just going to type them into Desmos. So we have our R of X, which equals 1958X, and our C of X, which equals 5211 plus, oops, I typed it in wrong, 1210X. And I can double check real quick. 15 to, yep, okay. So when do these two intersect? Well, it looks like Desmos from the last one I was doing. But let's say I had it on regular. I would have to kind of zoom out until I can see both of my equations, okay? And that gets a little difficult to do. Right, so let's try to find where they would be, okay? So you might think it's kind of hard for you to see where they intersect here. So let's just modify this. Let's go to 100. Let's go the other one. Let's type in, so we see something. Aha. All right, so we see they intersect. Just playing around the window a bit. Right there. So it's 72.45447. So you could solve and get the same thing, right, for when they break even. So how many more must they sell to break even? Around 72. So we're using Desmos here. So for the next question, it says, at a price of $4.71 per pound, the supply for cherries is 16,324 pounds, and the demand is 10,395 pounds. When the price drops to $4.27 per pound, the supply decreases to 10,826 pounds, and the demand increases to 12,680 pounds. Assuming the price supply and price demand equations are linear, what is the equilibrium quantity? Okay. So this is probably one of the hardest questions in the course. Okay. So let's talk about how we would do this. Okay. So let's, so we know that when we have $4.71, the supply is 16,324, and the demand is 10,395. And now with the new price, the supply is 10,826 and the demand is 12,680. So we need to use the supply and the price to get one equation for price supply, and the demand and the price to get another equation. Okay. So for our PS, we're going to use the following. And if you don't want really large numbers, if you do this on MATLAB or you look at the book for this problem, they convert the supply and demand quantities to something much smaller. Okay. So what they do is they use these two ordered pairs. So for price supply, remember price is the output, so the number for the supply would be the input. Okay. So we're going to use 16.324, comma, 471, and then we're going to use 10.862, 4. So we've cut it from like 16,000 to like 16 points. So it's just in terms of thousands of pounds. So use these two, get your equation. Okay. So what would our slope be? Okay. So if this is like x1, y1, x2, y2, you should get your equation. So you could practice. So practice from before. Right? x2 minus x1 over y2 minus y1. So you get your slope to be around 0.08 approximately. Okay. And now we're going to use the y minus y1 equals m times x minus x1. So y, minus 4.71 equals 0.8, and then times x minus 16.324. So then we're going to distribute the 0.08. And this is 1.306. And then y minus 4.71. And then we add over the 4.71. So 0.08x plus 3.404. So this is your PS, equation price supply. And now, as you probably guessed, we need the same thing for price demand. Okay. So our ordered pairs for our price demand is 10.395. And that's at $4.71. And then 12.680. And that's at $4.27. And another thing, if you don't convert X's, those demand and supply quantities, to something smaller, right? If you use actually 10,000 and 12,000, the slope would be super, super, super small, and sometimes it's hard to get the right result that way. So same thing here. We're going to do x1, y1, x2, y2. So then our m for this line would be, so we do y2 minus y1 over x2 minus x1. So practice, plug all those values in, and we'll arrive at approximately negative 1.1926. So let's just plug everything that's in. So y minus y1 equals our m that we get times x minus x1. So y minus, use your y1 point, 4.71, equals negative 1.926 times the quantity x minus 10.395. Same approach, we're going to distribute our m. So y minus 4.71 equals negative 1.926 x plus 2.002. And then last but not least, add over that 4.71. So we get y equals negative 1.926x plus 6.71. And now this is your price demand. So remember, you want equilibrium quantity, so that is the x value of the intersection. Okay. Where does your PS and so we're going to use Desmos, unless you want to do this by hand, which is probably not the best. Okay, so let's pull up Desmos here. Let's graph each one. So we have y equals 0.08x minus 1.306. Oh, I forgot my point. So we already kind of see the equation there. Let's have another line, y equals negative 1.926x plus 6.71. So where do these two intersect? So let's make sure. Oh, for some reason I typed in the wrong thing. Whoops. So this first one, there's an error. I was using the wrong number, so always double check. Minus 1.306. Oh, I did it again. What am I doing? So this is plus 3.404. Okay, much better. So we see here that this intersection is at 12.128. So that is where, so the first value, that is the equilibrium quantity. The price would be the y value, okay, the equilibrium price. So how many? So you want to think nearest pound. So we got 12.127. So that is not 12 pounds of cherries. Remember, this is thousands of pounds. So that would be 12,127 cherries, or pounds of cherries. So that's what we put here. You have to expand that number back out, okay? So thanks for watching. Look forward to the next video.